Hey guys, what's going on? So I am in the middle of a work day actually, and I'm working on this liquidity pool thing for our product. I'm super excited to show more of that product. I want to kind of start building a series around it because it's super exciting. But I got a little frustrated, to be honest. I was like, okay, let me shift gears a bit. Let me just dabble into some back-end engineering, sharpen the knife a little bit, let my brain kind of think on some things, and then I'll dive right back in. Super exciting. It's this whole front end, back end blockchain integration of a product that we're constructing, and it's really exciting. It's phenomenal piece of data aggregation, and the tools around it that we're building is just wonderful. So I really do want to share that with you guys, and I think it's goes to further the point of like, this is why we learn things, is so we could build really cool things, right? Like that's kind of why we take the time to sharpen the knife, if you will. And it gives me an opportunity to kind of build a plan on how to show you guys on building a proper product. So yeah, but that's just kind of where my head is at. But let's dive into this for a second. We left off on classes on the last episode for backend engineering. Let me move this up real quick. And what classes are, basically we can have, let's dive in. But basically we're building the model of how some data kind of looks and how it works within the system. So let's dive in, right? Multiple objects. If a class is just a type, then an object is just a value. You'll hear often that an object is just an instance of a class. Let's look at what that word means. In object-oriented programming, an instance of a concrete concurrence or occurrence of any object, an instance is a synonym for object, as they are a particular value. Each instance emphasizes the distinct identity of the object. Okay, so that's all fancy dancy talk. Instances, classes, objects, all this stuff. Basically, this is what they're roughly defining. This is an object, is at least when we relatively look at JSON. So let's say our object has an ID of 1. And let's say we had, let's just kind of ignore everything, right? I don't want to convolute what we're building. If we look on the right, it kind of convolutes everything with all the things we just read. But let's just build a basic object, right? Of say ID 1, maybe my name is Ryan or Pags in this case. And let's see, not sure why the spacing's off, but we'll go with it. And this is our object, right? So this is our instance of a class, is what they're saying. So let's say we have another piece of data, the ID is 2, and the name is David, right? This would be another instance of an object. But let's further read. So for our wall class, let me get all of our data out of here. I can create 3 different instances of the class, or in other words, I'll create 3 separate objects. Okay, so we have wall, this one, a different wall, and a different wall here of different heights, and I imagine different widths and different depths. So, okay, so in the example above, the wall and integer are types, and each variable is an instance of one of those types. So this would be an integer. So those are all integers. What we showed with our data, these are all strings, of course. Okay, so assignment, take a look at the brawler class and the fight function provided within this. Okay, so here's our fight function, and here's our brawler class. In the main function, create 4 new brawlers. So what we could do, where's the main function? Right up here. We could say argon equals brawler, right? And we can pass in kind of all these things. So we need to make sure that these integers are assigned to it. So of speed 4 and strength 4. So let's look at what we could pass into the brawler class. So it looks like we have speed, strength, and name. So we could go ahead and say 4, and then I imagine the name is more than likely going to be a string. We could verify that here in a moment. Okay, so this looks like it should be 1 though. And then call fight twice. Let's see. So argon. We got Gimli. He was one of my favorites. Just a classic little dwarf. Him, that little axe throwing guy. Okay, so we have Gimli. We got Legolas. Of course, he was smooth with the women. We all know that, right? And of course, we got Frodo. Okay, So, boom, and Frodo, he looks to be low speed and low strength comparatively. So, okay, so we have our 4 classes of these brawlers, or these instances, if you will. Boom, 1, 2, 3, and 4. And then we need to call the fight twice. The first fight should be between Argon. We'll actually put it in the main function even. But the first one should be between Argon, and Gimli. Okay. And the second one should be with Legolas and Frodo. So let's see. Legolas versus Frodo. Obviously Legolas is going to wax that. You know what I mean? Not even close. No way. We got it first take. Folks. That was awesome. First take here. So we did something right. We learned something. We did something right. Let's keep it moving. So 14 objects quiz. So a blank is an instance of a blank. A object is an instance of a class. Sweet. That's kind of what we covered with the data structure-y things. Okay, so archers. Complete the archer class. Constructor. The constructor should take and set as properties the following parameters in order. Name, health, number of arrows. Okay, so boom, we got name, health, number of arrows. So get shot method. Finish the method called get shot that doesn't take any parameters. If the current archer has health left, well, hold on. Let's see. So we're just working on this. Is my understanding? Oh, we got to do both. Okay, so the get shot and then the shoot method. Okay, so if the current archer has health left, so it looks like we can instantiate all these things here. So check this out. This is what we'll do here. We'll first do the work on this. So we'll say this dot self equals self, and then we'll say this dot name equals name, right? We'll say this dot health equals health. This dot number of arrows equals number of arrows. Okay, so we have our arrows, we have our health. Everything is instantiated here when this class is instantiated, or everything is constructed here when this class is instantiated. That's what this init allows us to do. So now we always have access to these variables. So now in our get shot method, now over here we should be able to say, okay, so the first parameter that they asked, if the current archer health is something, right? So we could say this dot health or self dot health, right? I believe that will work. If something like this, we could go, oh, I got a JavaScript syntax for a bit there. Can't be doing that, folks. Can't be doing that. Okay, so if health is above 0, or maybe it's this dot health, one of the two, we'll break some code, figure it out. So if the current archer health has left, remove 1 health from the current archer if they get shot. Oh, I see. Okay, so let's see. This dot health, let's see, minus equals 1. Yeah, I think that'll work. This dot health minus equals 1, or self dot health, one of the two. Yeah, is this all set up proper? Maybe it is self dot instead of this. Maybe it's all self. Maybe it's just that with Python. We'll break some code. We'll figure it out. Okay, so, and then if the archer's health is 0, right? So we could do an elif or just another if, right? We could actually even do a guard clause statement. So just do the logic bit first, because it's the one that would negate the rest of the logic, right? So if the health is 0, we could just go ahead and return, or it looks like raise the exception. So how do we do that in good old Python? Raise exception. Say self is, how do we do this, folks, right? So can we say self is dead, right? Something like that. Self.name. Got it. Okay, that's what they said. The curlies right here are the archer's name. So I think that's roughly gonna work. Roughly. You know, we'll mingle and mangle with it. We'll see. But that seems to be the appropriate logic. So first we'll just check if their health is 0. Okay, boom, knock it out of the park. I guess technically we could actually get real fancy on it. Say if it's negative or less than 0, do this. Else just always do this case. I guess technically would be some repertoire type programming potentially, right? Some logic here. So this way we're always well. I guess that would still allow it to go through 0, so it would work, but we'll just do this for now, and then we'll mess with it. Okay, so shoot method. Let's finish the shoot method called shoot. Takes an archer, so the instance as the target input. Okay, so it looks like it takes self as the object, and then also a target for maybe an instance of another archer. Okay, so if the shooter has no arrows left, raise. So we'll say if self dot of arrows. Let's go ahead and steal this. If boom equals 0, we can go ahead and raise an exception again. It looks like self dot name cannot shoot, right? Or boom is the shooter's name. Shooter shoot, baby. Shooter shoot, baby. Okay, so otherwise remove an arrow. So we're doing just similar logic here. So if self dot number of arrows is greater than that, we'll remove one arrow from the quiver. Otherwise, remove an arrow and print blank shoots 1. 1 shoots 2, where 1 is the shooter's name. Okay, so otherwise remove an arrow, correct. So we are doing the correct part, and then we just need to add this. It looks like some sort of exception here. So self.shooter, and then we'll say self.name shoots target.name, I think is the Django, the gist that we have here. Okay, so next, call the target's get shot method. Oh, fun. And then we could pass in the target, right? Kind of makes sense. Well, hopefully all goes well. We kind of did a whole bunch of logic there without checking very much, but let's see. We passed one test, so we know it's not going to work because we see a couple failed, but we passed one, which is fun. Passed one test. Okay, so let's see what's going on. So maybe we don't need this. Maybe we just need, no, self.num. Okay, so first I want to just check that the self is working, that all this init function is working, right? All the instantiations, if you will. So I'll say print self. Let's see here, and I'll put a bunch of stars. Stole this from my dear friend Chester. At least the star syntax, if you will. Let's see. I don't see a whole bunch of stars here, but I want to see. Okay, so let's see. Oh, there it is. Boom. Okay, so we have main archer object right here. Okay, cool. So we at least see something. Looks like got some sort of F8 2 bytes hex code, right? So fun. Gotta love it. So let's say self.name. Maybe we could get boom, Friar Truck, King Richard. Okay, so it is all instantiating, which is great. So that worked. Do we have, this is going to be a silly question, but do we have to do this? No. Self set to self, right? Because I'm not seeing the get shot method. Oh, you know what? We wouldn't need to trigger it, right? Because it does get instantiated. So, I'm trying to read this. So Friar Truck can't shoot pass. King Richard is dead. King Richard shoots Prince John. Fail. Expected is King Richard is dead. So I imagine that's one of theirs. Was that our job? To print it is dead? Oh, we do have that. If the current archer's health. Okay, so let's see what's going on here. If the current archer's health is dead. Oh, but this does have to be after, because it would, in logical sense, right? Let's see if that works now, at least for the King Richard one, because it would have to take away the health and then check it, right? No, never mind. That wouldn't work. Never mind. Forgive me. Okay. We're gonna steal Chat GPT real quick. See what I don't want to spend too much time on this, just enough to let my brain kind of marinate over a few things, right? Steal this, and let's see. I know they have the solutions, but sometimes I like to see the old Chat GPT real quick. We could take a peek at the solution too. So let's see. If health, self.health, boom, is this? So we looked like we did something right. Was it just literally the parentheses? Because I'm seeing a lot of these and they look target.get shot. Okay, so we did need that. Self.number of arrows -1. So I think maybe the parentheses was an issue, or the target just get shot needed to. No way. So was maybe some of these parentheses. Okay, cool. Well, let's try this then. Let's see. We have defined shoot target, so it looks the same. If self.number of arrows equals 0, raise the exception. Self.name can't shoot. Raise exception. Yeah, we had done that, right? Else, okay. Else self.name. We need to print that, not raise the exception. Okay, so that's one big bug too. That was probably the the biggest of the bugs. That was the biggest of the bugs, folks. Okay, great. And that's actually what ChatGPT said as well. So, and it said to add this bit right there. The target gets shot. Awesome. So we got that figured out. That's good. We did a lot of coding. Maybe we'll break up the next class one with one or two more steps before just running all of it at once. Okay, so class variables versus instance variables. Interesting take already. So far, we've worked with both class variables and instance variables, but we haven't talked about the difference yet. Below are two code examples that demonstrate the variable height being declared as an instance variable and a class variable. So it looks like this is an instance variable. This one is a class variable. So instance variable vary from object to object and are declared in the constructor. So instance in the constructor. Class variable looks like it's just part of the class, similar to a variable. So this one would be a class variable, but if it was in here, it'd be this variable. Class variables remain the same between instances of the object of the same class and are declared at the top level of the class definition, of the top level scope. Okay, so which should I use? Generally speaking, stay away from class variables. Global variables, class variables are usually a bad idea because they make it hard to keep track of which parts of your program are making data update. However, it is important to understand how they work because you may see them out in the wild. Okay, so this is our assignment here. We're now on the wild. We're taking on the assignment. We're doing what we need to do. Okay, so due to our terrible class design, some lazy code owned by a different development team is causing some bugs in our class. We can fix it by using instance variables instead of class variables. So it's a class right here, and it looks like we need to not do ice, but say self.element equals element. And I guess technically you could default it to ice if we need to. So we can actually do this, I believe. So that would be one thing, right? I don't know if we were supposed to do that or not, but I did it. But I did it anyways. So okay, so let's see this. So in the main function that our team isn't responsible for, a line dragon.element is assigned to fire should not affect our existing dragon instance. We don't near global variables. We want our users to specify each dragon's element in the constructor. Update the dragon class, remove the element class variable, and instead use an instance variable. So I think that'll work. Sweet guys, we did it. Okay, so now we're on to the challenges. We have C1, C2. Let's see what we have here. So local library. A new library just opened in a small town near you. But, okay, so they reached out asking you for help. Like a system to keep track of all the books in the library. Complete the library and book class. The book class, we need a title. We have all that stuff. So self.title equals title. And then we also have an author. So that gets added to the author here. And then it looks like we need to do the same for some of these. So self.name equals name. Say book here equals the book. What else do we need to do though? I don't want to get too far ahead. So initialize a .name member variable to the value name. Where is this in the init class? Do we need to add that? Or this is the library? Okay, so initialize a .name member variable to the name. Boom, boom, boom. Create a .books member. Initialize to an empty list. So if I'm reading that correctly, we'll put some random name here that we need books, which needs to be initialized to some empty directory. Is how I'm kind of reading that. I don't know if that's what they want, but that'll do for now. Let's see. So add book, a book instance to the books instance variable by appending it to the list. So could we take self.books and append the book, right? We'll roll with it. We'll see how it goes. Remove book. So we need to do that as well. If the book's author and title, let's see. So we do get a book up here. So we do have a title and author. Awesome. So within this little object here, what's really getting pushed in here is a title. Oh, computer, I think, there it goes. So we do get a title here, title, right? And then we have some author name. That's what's getting pushed into here. So that's our book data object. Let's try to remove it by the book title. So if I say self book, let's say author, that's going to be our key, I suppose. Well, what do we need to measure by? If the book's title and author. So we need both the book's title and author. So let's use these as keys, if you will. Title and author. Is this the boom? That's what I'm looking for. So we need author and we need title. Boom. So these are the two things we need to look for. Self.books. How do we remove again in Python? Is it just from an array? How to? Oh, where did that go? Where did that go? Whoops-a-daisy, folks. How to remove from array in Python, right? Is it just dot remove, but we need to find first. We actually just can't remove something. We need to find it first. Or could this be our book here? So we say book equals this, right? So this is our title, this is our author, these are the keys we're looking for. So boom, there's our title, there's our author. That's the book we're constructing, and then we need to remove this book from this local scope, this one that matches this. We'll see. They do have a search books function. I think we just kind of maybe worked around it. We'll see. For every book in the library, check if the search string is contained in the title or author. It's case sensitive. Return the book. Return a list of all the books that match the search string, ordered in the same way as they are. So I think we could actually take some of this logic here and let's see. So the search string one, that's a little bit tricky. Let's see. So the search string's coming in and it needs to match these things. Search string. Let's run it. Let's break some stuff. Let's see. I said we wouldn't do these huge functions initially, but we're here now. So let's break some stuff. Let's do it. Okay. Guys, I'm gonna run to the solution real quick. Let's see what we got. So self.books, we initialized it up here with the list here. So I'm going to tick us off on that. We just did it all up here. I think that'll still jive. I think that'll still work. Self.book equals this. Great. So we could probably actually remove that. That's just redundant. Don't need it. Remove book. So first he's looping through. How does he do the search? If search, lower string, boom, book.title. So we just did this key value syntax a little different. Obviously did not get that right. So remove book, for lib in self.books, if book.title. Oh, fun. Okay. For lib in self.books. Okay. That is cool. That is a good way to do that. For lib.book in self.books, if lib.book.title and libbook.author equals, same on the other side, right? The book.title and the book.author. We got to do something. We got to remove it then. So then self.books remove lib_book. So I think that'll do that. Search books, that was a whole ordeal. So that'll work if book.title equals this and boom. Oh, I had missed this, guys. I'm so tired. Sorry, my head's not fully in the game right now. I went on this 6 a.m. run, super fun. It's this run club. People are running around in the mornings. We ran 3.5 miles, and these guys it was nothing to them. I was doing my very best, and I did okay. And they were sweet. They were like, hey, we could go a little bit slower for you. We'll take our time. Don't you worry. It was still quick pace. It was still good, But yeah, they do like marathons. As one of the dudes is training for 100 miles, and we just did 3 today. Holy crap! Okay, so define search.books results. So we're going to instantiate an empty array just for a little bit of memory. And we do book in books if the search string is in. Oh, you could do that in Python. That is so cool. Nice. Okay, I'm going to try to remember that out of memory. Let's see here. So we'll just do results equals some sort of empty array. Say for book in that self.books. if, what was it? If there was two statements that we need. So if the book title, two lowercase, right? Just to obviously sure that if someone puts a capital in or lowercase, it doesn't affect anything. But if that equals the search string to lower, is it too lower or just lower? Too lower or just lower? Or same thing, just with the author, we need to do something. I think they did a little bit fancy syntax here. Something like this, a little bit more legible. Then we need to say results.append book and then return results, right? Let's see. We're going to let it rip from the top. 3 failed. Golly. I know I'm close. So let's take this out. Let's not do this fanciness. Did this need the name? I forget. If it needed a name or not, or what the deal was here. All right, let's see. Let's take a peek-see. So if lib.book in self-books, looks like we're there. Oh, they did not have books here. Self.books. That'll throw something in the test for sure. So self.books, where did I change it? Where did I go wrong? So book.author, boom. Shouldn't matter if it's libbook on the left side, book title on the right side. That shouldn't matter. Shouldn't affect anything. Libbook.title. Oh, I see. Got it. Okay. So this is where my logic is not appropriate or not correct. Perfectly appropriate logic. Depending on what you're doing, right? So we're checking the lib title, the one in the library, and then the book that we're removing. Okay, so then we have for book and self books. That looks proper. Proper. Search string to lower equals the title to lower. Yep, that should be all good. Should be, in theory. Should be. Again, not sure why it's not oh, right here, boom. In. Got it. So this order would matter. Can't just check comparison on that. Okay, cool. Let's try that. Nope. I don't understand why it does the red when I don't see the difference. Libbook for libbook and self books. We just invented libbook, right? Folks, I'm not sure. So John Bohm actual, so expected to kill a mockingbird. I don't want to waste too much time here. So I'm trying to see self-books.remove, libbook.title, book.title. Well, okay. I guess we'll try comparison on the other side. It really shouldn't matter. Really should not. Oh, you know what, though? That might do it. Book title, boom, book author. Okay, so that'll work. So for libbook in self.books, where's the difference on our side versus their side? I don't see it, but we have a different highlight. I don't understand. For libbook and self-books. For libbook and self-books. Did I rename something wrong? For book and self-books. I also don't see the difference here. Maybe just minor spacing stuff. Okay, so search string to lower in book. Should all be fine. Even the spacing is all whatever. It really shouldn't matter too much. So book author to lower or search string down. Where is the difference on this one? Golly. There. Okay. And finally we return the results. Oh, that was out of scope. Okay, so that would actually do it. That was probably the kicker the whole time was returning results out of scope, because that's going to return it on a different thing versus, yeah. So let's actually undo all that stuff. Now I'm curious. And just back this up. Yeah. That's what I figured. Okay, so we are at the final challenge, golly. So employee management, you've recently been hired to work at a new startup, boot.dev or dev.boot. The company has yet to implement any system for tracking employees within the company. Your manager has assigned you the task. Unfortunately, dev.boot engineers kind of stink. That's why they hired us. Why they hired the the big guns. Okay, so the company creating a company class that uses instance variables to track employees. They've decided to use an employee class that uses the class variables to track employees. So instead of creating the company class, they've gone with the employee class. Great. It's not the cleanest implementation, but you're stuck with it. Hey, at least you get to practice using variables, class variables. Okay, so initialize the following variables. So company name, set it to dev boot. We'll steal that. And then we need to initialize the deal to which is already done for us. So constructor, we need to do all this. Boom. Let's see. We actually just copy all of these down, and I'll do self dot first name equals boom. Self dot last name equals that. Boom. Self dot ID equals ID. Boom. Self dot position, position, boom. Self dot salary equals salary. Okay, cool. So that we instantiate all the self classes. Great. Also, it should increment the total employees class variable each time a new employee is created. So each time there is a constructor, let's see, the ID should be plus equals 1 roughly. So let's see, roughly how to do this. So the totals employees count right here. Just do that. I think that'll do the job. Add a get name method that returns the employee's full name. Okay, so we say print, or we could return self dot. Oh, it's first name. Got it. Okay, so self dot name plus a space plus self dot last name, right? Alrighty. We passed none of them. How did the what do you mean? What do you mean? The corrector should take in order the correspondence here. This seems about right? Total employees is not accessible there. I see. Do they not want it? So it's a class variable. Huh. So error. So how many things would we pass here? Okay, so we're returning the right name. It's just not the right count of employees. So that's the last bit we just need to figure out. It's getting the employee. What if we just did this? Would that work? Nope. So it gets initialized to that. Can we not just, is there a this, or can I do self dot total employees equals this? Would this work? Maybe. No. This isn't defined. Of course, that's not the right syntax. Silly me. Okay, let's take a look, see at this solution. So we actually have to call the employee total employee. Got it. Rookie move, folks. Rookie move. Okay, so boom, like this. There we go. Nope, still missing one. Self dot first name equals first name. Nope, that should be good to go. Yep, this return should still be good to go, whether it's an F string or like this. Still shouldn't really matter too much. We had all the right names down there, so we saw that. Why is it oh, I still have this. Yeah, that's not gonna fly. All right, folks, we got there. Well, thank you so much for diving. This is just an amazing game. We're gonna dive into some encapsulation on the next episode. It's good old time wrestling with it, good old time wrestling, learning about classes and instances, and it's a really important concept to understand, because when you talk about inheritance, encapsulation, proxy contracts, proxy classes, all these things are actually stacking on top of each other. So super important. I will see you on the next one. Cheers.